Hey, this is Step Amit. Welcome to my Exorcism.io series. In this video, I'll be working through the RNA transcription exercise from the Exorcism.io Ruby track. So for this exercise, we're going to be given a DNA strand, and we have to return its RNA complement. So each of these things, a DNA strand and an RNA strand, is a sequence of nucleotides represented by a series of letters. So for DNA, the letters we have are A, C, G, and T, representing these chemicals. And in RNA, the letters are almost the same. It's A, C, G, and U. And if you're given a DNA strand, its transcribed RNA strand is formed by replacing each nucleotide with its complement. So these are the complements here. G becomes C and C becomes G. T becomes A and A becomes U. So that's how these work when going from DNA to RNA. So let's go ahead and grab this and we'll get started. And I'll go ahead and start a new TMX session. All right, let's go ahead and open up our test. All right, we have a complement class with a class level method of DNA. And so we're going to pass in a string and return the complement. And it looks like we've got a bunch of individual tests to make sure we get the right complement for each letter. And then we've got a test with a whole string here returning its complement. Okay, so let's just get started. Open my test running pane and go ahead and run my tests, which will fail because I haven't created the class yet. So let's do that. Start by just creating the file and trying again. Now it's going to complain because I haven't actually initialized the class. That's what this uninitialized constant means. So let's just do that. Now we need our class method of DNA. And this will get us to our next error, which will complain about the arity. Wrong number of arguments given. So what we're going to be given is a DNA strand. And we're returning, it fails because we're returning nil, but really we need to return an empty string for our first test. Now this test will pass, and we can move on to the next one. This is going to fail, of course, because we're returning an empty string, and we need to be returning a C in this case. And so at this point, we actually need to implement the functionality that we need for this. So there's a couple of ways you could do this. I mean, one way, and this is the way that I think when I was a newer programmer, I would have reached for it. In fact, in some cases, I might start out this way. Would be with either a big if-else chain or like a case or a switch statement, but that's not what you want to do. And maybe that's okay when you're figuring out what the class needs to do to start that way, but that's not what you want to where you want to leave it. When I think of this sort of thing here, where I've got a set of values passed in, and each one results in another value over here. I immediately think of a dictionary, right? I'm looking up, I've got a key that always gives me a value. I've got a key that gives me a value. That's a dictionary. And the way that we do that in Ruby is with a hash. So what we can do here is I'll just start building it out right here. Let's call it nucleotide pairs. And I'm just going to start building it out right here. The one that I know here is I have a key of G, and it's going to return a C. And then whatever I was passed in, so let's do this just to make sure our tests are going to pass. I'll put in an empty one. I don't think we'll need this at the end, but for now, I'm going to do it this way. And what I want to do is I want to take my DNA strand, I want to look it up in the nucleotide pairs and return the complement. So I can simply use DNA strand right now as a key and return the value from the hash. Expected G, actual nil. What? Oh, I did the reverse. Sorry. Read my expectation backwards. And you may notice already this is not going to work for our final example down here, but I'm not going to worry about that yet. What I want to do first is I just want to build up my dictionary here, build up my hash. So now we need to do the opposite. And then when we get to the end, we'll deal with having a whole list of these things. That'll fail because we don't have this pair. We need T to return A. And then now we need U, or A to return U. All right. So each of these pairs works, including empty. And you see, I need this because otherwise I'll have nil, which is not what I want. I mean, I could 2S, whatever I get at the end here. I guess we can just do that for the moment. But let's deal with this last one. Let's figure this out here. This is going to fail, of course, because we have this long string. And we can't we can't keep adding to this, to have every example possible, because it would be infinitely long, and we can't do that. So what we have to do is we have to take each one of these and replace it with its complement. So anytime I see this where I've got a list of things here, and what I want is to replace it with another list of things that is the same length as the original list of things, I think of the map operation. I want to map over this list and transform it into this list. But what I have here, is a string. It's not a list. So how do I turn my string of characters into a list or an array of characters? Well, the first thing I think of in splitting a string, you could split it like that, and that will work. Let's just get this down here. That would give us an array. If we split it like this, see, because split will do that. You can split on an empty string and get that, but there's actually, I think, a better, more expressive method here on string called each char that will literally give us each character. That's exactly what we want, and I think that's more expressive of our intent. Each char. So each char is going to return the array that we want, and we want to map that. So let's just go ahead and do a long form here. We've got the character. Let's call it nucleotide. I'm going to expand this. If I can spell nucleotide. And really what I want to do is each one of these, I want to return, I want to look up this nucleotide in the nucleotide pairs, and I want to return 2S. But this is going to leave me, this is going to, if you'll notice, if I run this, it's going to fail because I have an array. So I just want to join those together. And I think I can actually get rid of this 2S here because that empty string I have from the first test, it's going to be each char is going to give me an empty array. And when I join an empty, and so it won't even get in here. There'll be nothing to map. I'll have an empty array at the end of map. And if I join that back together, it'll give me an empty string. Okay, cool. So this actually works. This does everything we need it to do, but we want to refactor this a little bit to be a little bit more maintainable. I mean, there might be a time when we would leave it like this. I guess the good thing about this is it's all together right here in this method, so that if we need to move it later or do something else, it's all right here. I'm not having to look all over the place. But let's go ahead and pretend like this is production code, and we want to refactor this. I think the first thing I see right off the bat is the definition here in line of these nucleotide pairs. I want to pull that out into constant like this. Let's go ahead and pull this up here to the top of the class. All right, that still passes. And then there's one more thing I see here that I think could make this a little more compact and a little clearer. And that's by using the shortcut, the pretzel colon shortcut syntax with map here to map these guys to one another. And if you have ever seen, you probably are familiar. If you watch my videos, you've seen me do this before. Map also has a shortcut version that you usually see something like this with an atom, like 2S. So you could, and what this would do is this unary ampersand character will convert whatever's after it. It will call toproc if you on whatever's after it to get a proc. It also does the opposite. It converts back from a block to a proc. I think is how you say that. But here it will call toproc and whatever you give it, and return a proc. And for an atom like this, toproc will return a proc that will call this method name on whatever element it's given. And so this map will pass each element to the proc here. So what we can look at here, we can see if I look at hash implements toproc. And it returns a proc which maps keys to values. And so if you have a list of keys, and it will simply call each of those keys and will return the value. That's exactly what we want to do here. So I can simply pass the hash, and it will do the same thing there. And of course I need to join it. And so again, let me explain what's happening here. The unary ampersand will call toproc on this hash here, which will return a proc that takes a key and return the value. Map will then pass each char to that proc and return an array with the results. And then, I mean, that's exactly what we want to do, but it's much more compact. So let's actually make this a little more readable by simply putting each, I like to put each operation on its own line, so it's pretty clear. It's much clearer what I'm doing. I take the DNA strand, each char, I'm mapping it using the hash, and then joining the results back together. I think that's much cleaner. This is what I would want to commit and ship. So, all right, let's do it. And so let's see, submit transcription.rb. All right, cool. I'll see you in the next exercise.